Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. So now let's continue to the second part of your chapter 3. So at the previous part, you have learned about transformer where it will step down the 120 volt here to a smaller voltage, let's say 12 volt. So the first formula that you learned before is V primary divided by V secondary equal to N1 divided by N2. Now we move to the second block diagram, that is what we call rectifier. So what is the function of rectifier? The output from the transformer is still a sine wave because it's just step down the voltage, the amplitude. So inside the rectifier, what is the role of the rectifier is the process of converting an AC voltage, the alternating voltage, into one that is limited to one polarity. So you will change at your sine wave. Let's say here you have plus and minus. After you go through the rectifier, it will change everything to positive polarity. So you will have only one polarity. Your negative polarity will be either eliminated or it will be changed to positive polarity. So that is the role of your rectifier here. So there are two types of rectifier. The first one is half wave rectifier. The second one is full wave rectifier. Okay, so what is the function of rectifier? Is to convert AC to only one polarity. So if you see inside the AC adapter previously, so you have the big one here is what we call transformer. And there are 4 diodes here, so this is a diodes. So when there are 4 diodes, we call this full wave rectifier. Full wave rectifier. So half wave, you only have one diode. Okay. So what will this diode do? So after your transformer, let's say before your transformer, the voltage is 120 volt, it's very high. You go through the transformer, it will step down the voltage to only 20 volt. Okay, and after you go through the rectifier, it will change from 2 polarity to only 1 polarity. So this is the function of the rectifier. Okay, so this is an example of half wave rectifier. So what is half wave rectifier is you are going to change one polarity to two polarity to one polarity. So half wave rectifier, you only have one diode. So you have only one diode here. So this is the input from before transformer. So this is what we call V primary. And here is your V secondary connected to the one diode and in series with what we call resistor. Okay, so how are you going to solve this circuit? We want to derive what is the voltage output for your half wave rectifier. Okay, the input from the secondary here is a sine wave. So let's say we start with the positive polarity first. So when we're talking about positive polarity, you need to put here plus and minus. So let's have the KVL. So let's say this is the PLM1, where you're going to replace your diode with V gamma, that is 0.7 volt. So your circuit will looks like, here will be plus minus Vs, and then is the diode turned on or off in this cycle? So since it is plus and minus, it connected to diode plus and minus, right? So means this will be turned on, and then you have a resistor. So by having a KVL here, what is the equation? Minus Vs. So since your Vs is a sine wave, so when you have a sine wave, we have what we call here V peak, the primary. So always write the word here peak for chapter 3. So minus Vs plus, now since this PLM1, you're going to replace your diode with V gamma. So become V gamma plus. So the voltage drop at your output here is actually V out. So we got V out equal to 0. So what is your V out? Vs. Don't forget the peak minus V gamma. So this will be equation number 1. Now let's move to the input back. So how about the negative cycle? So this is your Vs, right? This is your Vs. So at the negative cycle, so what you need to change here, instead of here plus minus, you need to change here minus. plus. So this is your Vs. And then you have a diode, and then you have the R. Okay, so this is here is minus plus. Let's say I change here, it become minus plus, but your diode need to be plus minus, right, in order to turn on. So when it connect to the minus plus, so then the diode will be off. So when it is off, it will be open circuit. Now what will be the value of V out? Since it is open circuit, no current, and your V out will be equal to 0. Okay, so the last steps where we are going to draw the graph. So let's say this is your graph. This will be your input. This is your Vs primary. This is V voltage, and this is T second. Okay, so now let's draw the output graph. So for the output graph, means that after the rectifier, what will happen? Okay, so we need to see in what condition where your Vs is, your diode will be starting to turn on. So remember just now your V gamma is equal 0, let's say 0.7, right? So if you insert your Vs here, now you start your Vs here, let's say 0.2. So your V gamma, what is V gamma? V gamma is the turn on voltage. Your Vs is 0.2. So will the diode turn on or off? It's still less than V gamma, right? So it's not enough to turn on. So your output will be still be 0. So in what condition will you start to be turned on? So when your, this only will happen when your Vs is more than V gamma. So let's say your V gamma is 0.7. So let's say this is your V gamma 0.7. So how you're going to plot the output graph? So less than V gamma, it will be 0. So less than V gamma, it will be 0. Now, what means when your Vs is equal less than V gamma, your output will be 0. Why? Because the input is not enough to turn on the diode. So when it starts to become more than V gamma, so it didn't overlap. V out and Vs is not overlap. So it will be reduced, right? Because it will be minus V gamma. So that's why you have it this shape. Okay. Now what will happen at this is happening at the positive cycle. What happened at the negative cycle? You know, at your negative cycle, it directly off. So means here will be totally off, and then it will be repeat again by itself. Okay. So means at this condition, why this one is off? Because your Vs is still less than V gamma. Here, it will become on. And here, why it is off? Because it's negative, right? Also become less than V gamma. So the diode will be turned on and off accordingly, depend on what you're going to plug in inside the input. Okay, so if you see the same explanation, when your Vs is less than V gamma, at the positive cycle, this one is at the positive cycle, means at this part. But if it is still less than V gamma, you don't have your V out because the diode is off. So second condition, when your Vs is more than V gamma, diode will be on, right? And how you can get this equation from the KVL previously. Okay, and this equation is coming from the KVL equation. Okay. So the orange color of the graph here is what we call V out as explained before. So the blue is actually your V input Vs. Okay. So when your Vs is less than V gamma, so means at this area, when your Vs is still less than V gamma, your diode will be off because it's not enough to turn on, right? So that's why here will be 0. Okay. So at this area, so means at this area happen when your Vs is more than V gamma, right? And it start to turn on, and that's why you got your V out here equal Vs minus V gamma. and this is happening at the positive cycle. What will happen at the negative cycle is will directly off. That's why from here to here it is off, and then it will be repeat by itself. Okay, so take note here, we only take the peak value for chapter 3, so you can drop the sign. So that's why you say here Vm is the peak value. Okay, so let's do one example. So in this example here it says R equal 1K, V gamma is 0.6, and suddenly we have RF. So when you see this RF here, so this just means this is PLM2, where you're going to replace your diode with V gamma in series with RF. Okay, so let's look at the question. Your input here is a sine wave, so this is a sine wave. So that's where you have 10. So what is the Vs peak here? It's actually 10 volt. So how are you going to solve this? First, at the positive cycle, what will happen when your Vs is less than V gamma? Means it's not enough to turn on, right? So diode will be off. Your V out will be equal to 0. Second condition, when Vs is more than V gamma, means it is now become 0.7 or 0.8 or more, your diode will be start to turn on. So when your diode start to turn on, you need to replace your diode with what we call V gamma in series with RF. So the two elements here is actually your diode. So what you need to do now, you just do the cycle. So just now at the positive cycle, you make it here plus and minus. So let's have the KVL equation. Starting from here, minus Vs. So don't forget the peak value. Plus. So now the diode is replaced by V gamma and RF. So become V gamma plus RF ID peak. Okay. Plus R ID peak equal to 0. So do you know your Vs value? So your Vs value here is 10 volt minus 10. Your V gamma is 0.6. Your RF is 20. You don't know your ID peak. And you are given R is 1K. And again, you don't know your ID peak equal to 0. So this is one unknown, one equation. So you can solve for your ID peak value. Okay. So this is at the positive cycle. How about at the negative cycle? So what you need to do now, you need to change here instead plus minus, you need to change here minus plus. So when you change minus plus, what will happen to the diode? Diode will be off. So means V out will be equal to 0. Okay, so let's try to plot. So you are given a circuit. So this is your input Vs. What is your peak here? Your peak here is 10 volt. So let's redraw the output. So first condition, at your positive cycle, you have Vs equal minus V gamma, and the diode is turned off, right? So here is turned off, here is turned off. And then when it is more than V gamma, so it start to turn on, and you are expecting here this the V out will be much more lower, right? So it become inside. Okay. At your negative cycle, so when you do negative cycle, means you need to put here minus plus. Your diode is off, V out is equal to 0. So you're going to have a straight line. Okay, so let's find out what is the peak for your V out. So just now you get your ID is 9.22 milliampere. So how you can get your V out is 1K times 9.22 milli. You can get here 9.22 volt. So please don't forget to label here. It become 9.22 volt. Label here, this is your V out. And this is your VIS. Okay, and this is T, your second. And this is your V out. V only. V. Okay. So this is the important thing when you want to plot the graph. So don't forget to label the input, output, the amplitude, and the unit for both X and Y axis. So this is how you calculate your half wave rectifier circuit. Okay class. Assalamualaikum warahmatullahi wabarakatuh.